Hello beautiful people and welcome. In today's video we are going through the Integrated Math 1 Chapter 4 practice exam. As a reminder, I am human, so if I make a mistake, please let me know where the mistake occurs so that way I may learn from it. Alrighty, let's jump into question number 1. In question number 1, they are giving us two pieces of information. They are giving us a slope and a y-intercept. That means we are writing this equation in slope-intercept form. Slope-intercept is y equals mx plus b. M is your slope, b is your y-intercept. So we have y equals mx plus b here. Our slope is 1/4. Our b is the second number of positive 12. So for our answer, we have y equals 1/4 x plus 12. For question number 2, it is also asking us for slope-intercept form. Here we have a choice. You can either use the slope formula or you can count slope. I'm going to choose to count slope. 1, 2, 1, 2, 3, 4. And then we have the increasing or decreasing question. Is it going uphill or downhill? This line is going downhill, so that means our slope is going to be negative. So how many ups? 2. How many overs? 4. Make sure to simplify your fraction. And then for your y-intercept, you're going to take a look at your y-axis. Here's your y-axis, and see where the intersection happens between your line and your y-axis. For us, it is here. You're going to take a look at what number this is. This is 1. So our y-intercept is at 0, 1. So we're writing our equation again. Y equals mx plus b. Y equals, what's our slope? Negative 1/2. What's our y-intercept? A positive 1. All right, let's go and move on to question number 3. Question number 3 is a 3-part question. It is asking you to write your equation in slope-intercept form. But before we get to slope-intercept form, we need to do two things. The first thing we're going to do is we're going to solve for slope. And for slope, we're going to use our Chapter 3 formula, y2 minus y1, x2 minus x1. So for our slope, let's label our points and plug in our information. For our points, we have x1, y1, x2, y2. Okay, y2 is 17, y1 is negative 4, x2 is 0, x1 is 7. Using a calculator or doing this by hand, we have 21 and negative 7. Make sure that you are simplifying, again, either by calculator or not. 21 divided by negative 7 is a negative 3. And what did we just solve for? That is your m value. After you solve for slope, you're going to use the point slope form, which is y minus y1, mx minus x1. Now we're using this point to start our equation, and then we're going to put it in the correct form, slope-intercept. So I already put in negative 3 for my m, y1 was negative 4, and x1 was 7. Simplify any double negatives that you have, making them into addition. This is not your answer. This is just in point slope form. Step number 3 is what we want for our correct format, slope intercept. Take that -3, multiply inward, make sure you're multiplying by -7. Y plus 4 is equal to -3 times x, which is -3x. -3 times a -7 is a positive 21. Now this is not the answer still because we need to solve for y. Subtract 4, and we're going to get our answer as y equals -3x. 21 minus 4 is a positive 17. This is your answer. All right, moving on to the next question, question number 4. Question number 4 is quite similar to question number 3, except that they are giving us a graph. So we can, instead of solve for slope, we can count for slope. Again, how many ups, how many overs? 1, 2, 3, 4. 1, 2. So we have 4 over 2. Again, are we going uphill or downhill? Since we're decreasing, we are downhill. So downhill, we are at negative. And again, simplify that if you can. And in this case, yes, we can. -4 divided by 2 is a -2. And that's your m value. After you find your m, we're going to move on to the point slope form, y minus y1, m x minus x1. Now I'm writing it on top because we're going to have to plug in our values and then simplify. So our values are y1. So when you're given a graph like this, you don't technically have a y1, x1. It doesn't matter if you write this as your y1, x1 or this one. I'm going to just choose 1, 2. Again, if you choose this bottom one, it will give you a different equation, but it's going to be the same equation. So we have x1, y1. So we have y1 is 2, slope m was -2, and x1 was 1. Any double negatives? No, so we are writing our point slope form. Y minus 2 is equal to -2 times x minus 1. Now, from your point slope form, you're going to distribute that -2. So we have y minus 2 is equal to -2x. -2 times a -1 is a positive 2. We're going to add 2 to both sides, get y by itself, and we have our slope intercept form at y equals -2x plus 4. And that's going to be our answer. So we have 2 different answers. I'm going to erase, no I will not. I'm just going to put a box around it. So we have 2 answers, one in point slope form, one in slope intercept form. One more time, let's do the exact same thing. This time we do need to solve for slope. So that's our step number 1. I'm not going to write the slope formula again. You can go back to example number 3 or question number 3. x1, y1, x2, y2. y2 was 13, y1 is 15, x2 is -5, x1 is -3. Again, using a calculator, if you need to, go ahead and simplify that. 13 minus 15 is a -2. Double negatives, that's addition here. Or you can just type it in exactly how you see it into your calculator. -5 plus 3 is a -2, which gives us a slope of 1. Make sure you simplify your slope. Again, for the point slope form, we want to first write out the formula. Then you want to plug in your values. Oops, let's make a little spot there. simplify, and then that's going to be your answer for your point slope form. y1 is 15. Slope we just solved for was 1, and x1 was negative 3. Simplify any double negatives that you see, and we have our point slope form at y minus 15 is equal to 1 times x plus 3. Now you can choose to not write that 1, or you can choose to have that 1 there. Doesn't matter. It's the same thing. All right, for slope-intercept form, you're going to distribute that 1. If you chose not to write it, you can skip the distributing step only if your slope is 1. So we have y minus 15 is equal to x plus 3. And then we add 15 to both sides. We have y equals x, 15, 16, 17, 18. Here is our answer for your slope-intercept form. For the next one, question number 6, I'm going to color code this for you guys because there are a lot of things happening here. So here is line A in yellow. Here is line B. And then here is this line C. So we have a yellow, a darker pink, and a lighter pink. What this is asking us, it's asking us to determine if lines are parallel or perpendicular. Parallel lines must have the same slope, but different y-intercept. While perpendicular lines need to have opposite reciprocal slope. So what this question is asking, are these lines with the same slope? Are they opposite reciprocal slope? What are they? Now you have a choice to make. You can either use the slope formula or you can count your slope. Because there's so much happening here, there's so many numbers, I'm going to choose to use the slope formula. And I'm going to split this up. So we have a line A, a B, and a C. And again, I'm going to try to color code this for you guys. And then let's take a look at what the 2 points are on the line and then use it with our slope formula. So for A, I'm going to take my finger. I have a negative 5 and negative 4. And then my second point is at 3 and negative 1. Negative 3 and negative 1. Next we have our B. Where's B? B is at negative 6 and negative 4. And what's our second point? At 2, negative, and negative 6. And then C, we have one at negative 3 and negative 6, and 0 and negative 1. Again, label x1, y1, x1, y1, x2, y2, x1, y1, x2, y2. Again, using your slope formula, we're going to find the slope. Now, if you're choosing to count, that's fine. Just be careful because, again, a lot is happening in that small little graph. All right, x2 is negative 1. x1, let me take that back because that's wrong. y2 is negative 1. y1 is negative 4. x2 is negative 3. x1 is negative 5. y2 is negative 6. y1 is negative 4. x2 is negative 2. x1 is negative 6. y2 is negative 1. y1 is negative 6. x2 is 0. And x1 is negative 3. Again, using a calculator if you need to. We're going to have negative 1 minus negative 4. We get a 3 on top. Negative 3 minus negative 5. We get a 2 on the bottom. Next, we have a negative 6 minus a negative 4. That's negative 2. Negative 2 minus a negative 6. That's a 4. Again, simplify if we can. So negative 1/2 is our slope here. And then the last one, negative 1 minus a negative 6. That's a 5. 0 minus a negative 3. And that's a 3. And then you can always double check your slopes by counting. So let's go to A, which is yellow. 1, 2, 3, 1, 2. So we had 3 up, 2 over. It is increasing, so that's good. Next we had was a negative 1/2 on the darker pink. So that means I'm going up 1, 2 over, up 1, 2 over. And that works too, so that's good. And then C is 5 over 3. 1, 2, 3, 4, 5, 1, 2, 3. And that's an increasing, so positive. Perfect. So our slopes are all good. And now we're looking at, are any of these slopes exactly the same? No. So since they are not exactly the same, none are parallel. Okay, any of them opposite reciprocals. So opposite means positive, negative. So these are opposites, positive, negative. These are opposite, positive, negative. But we need an opposite reciprocal. Reciprocal is where they flip the fraction. So I have a 3 on top. I have a 3 on the bottom. I have a 2 on the bottom. Do I have a 2 on top? No. I have a 2 on the bottom, 2 on the bottom. So none of them are opposite reciprocals. So that means none are perpendicular. All right, let's move on to the next one. All right, next one is a similar question. It's asking if it's parallel or perpendicular. And with parallel perpendicular, we want to know if they are same slope or opposite reciprocal slope. Here they're giving us 3 equations, so I'm going to set this up again as a table. We have line A, line B, line C. For line A, we have y equals 6x minus 2. We have for B, (6y) equals negative x, and for C we have y plus 6x equals 1. Now we want to set each one into y equals mx plus b format to identify the slope. So this one is y equals mx plus b already, so slope is 6. This one is not, so we're going to divide by 6. So y equals negative 1 6x. That means slope is negative 1 6. Here we need to do a little bit more. Subtract 6x both sides. Y is equal to negative 6x plus 1. So that means slope is negative 6. All right, same question. Are any of these exactly the same? I have a 6, I have a negative 6. Not exactly the same. I have a 1/6. Nope. So that means none are parallel. Are any of them opposite reciprocals? Again, opposite is plus or minus. So these are opposites. 6 is a positive, 6 is a negative. But a reciprocal is where they flip the fraction. So we can rewrite 6 as 6 over 1. Here we have opposite. This is positive. This is negative. 6 is on top, 6 is on the bottom. 1 is on the bottom, 1 is on top. So that means that line A and line B are perpendicular. So this is your answer here. All right, next one, write an equation of a line that passes through the given point and is parallel. So here we need keywords. They want parallel, so that means they want the same slope. Step number 1, you're going to identify the slope from the given equation. Write that equation out, make it into y equals mx plus b. So for us, that means we're going to divide by 2 each number. Y is equal to 3/2 x plus 10 divided by 2 is 5. That means my slope is 3/2. That's what we need from step number 1. Step number 2, you're going to use your point slope form to write out your equation with the same slope. Here's x1, y1. Slope was 3/2, and x1 is 2. Simplify any double negatives. And then step number 3, you're going to take that equation, continue working with it by distributing that slope and solving for y. Now, yes, you do have a fraction. Don't let that scare you. We're going to use our calculator. So you're going to copy down that y plus 5. That's fine. 3/2 times x is just 3/2 x. And then for the calculator portion, you're going to put 3/2, so 3 divided by 2 in parentheses. And then you're going to times it by a -2. And you get -3. So sometimes, even though it's a fraction, it gives you pretty numbers. One last step, we're going to add 5 to both sides. So y is equal to 3/2 x plus 2. And this right here is your answer. Oh, and I did make a mistake, beautiful people. Hopefully you were screaming at me. Since we have addition, we need subtraction. This should have been a -5. Almost. So 5, 6, 7, this should be at 8. I'm glad I caught that. I'm happy I caught that. So -5. All right, let's do it again, except now we're doing it with an extra step. And that extra step is because they want perpendicular. Perpendicular means opposite reciprocal slope. For your opposite reciprocal slope, there's just going to be one extra step. Step number 1 is exactly the same. Take the given equation. You're going to solve for y because we need to solve for the slope. Here we need to subtract 4x. We get 2y. Here we get -4x plus 12. And we're going to divide by 2. We get y is equal to -2x plus 6. That means my slope is -2. After you get your slope, that's where you're going to do the opposite reciprocal. So since this is a negative, opposite would be a positive. Since this is a 2, opposite will be a 1/2. We would flip it. So that means my new slope is a positive 1/2. After you get your new slope, you don't need the old one. This one's gone. It disappears. Then we continue just like we did in our previous example. We're going to write out our y equals, just kidding. We're going to do y minus y1 equals m times x minus x1. Plug in our points. Here's x1, y1. Our new slope is 1/2. And we simplify, distribute, in step number 4. So again, just because you see a 1/2 fraction, it's okay. 1/2 times x is just 1/2 x. And then we can type our calculator 1/2 in parentheses and then multiply it by this -8 times -8. That is a -4. Add 1 to both sides and you're almost done. We get -3 here, and this is our answer. Alrighty, question number 10, determine whether the sequence is arithmetic. If so, find the common difference. So here, if the sequence is arithmetic, there will be a common difference. If it's not, there won't be a common difference. So the way to find common difference, you're going to take your right, subtract your left. So you're always going to take two numbers at a time. Then you're going to shift over. So I'm going to ignore 14. 14's gone. Here's my right, here's my left. Oops. Then I'm going to, again, move over 1. Here's my right, here's my left. Use a calculator if you need to. 11 minus 14 is a -3. 8 minus 11 is also a -3. 5 minus 8 is a -3, which means your common difference is -3. But that's not what they're asking. It's a two-part question. It's saying, is this arithmetic? If so, what's the common difference? So the common difference is -3. What does that mean? That means, yes, arithmetic. So it's a two-part question. For question number 11, it's saying write an equation for the nth term. So I'm going to highlight nth because nth is going to be important of the sequence. Then find a sub 52. First step is we want to find the common difference. And again, taking your right minus your left, so 2 minus 4. Taking your shift over. I'm going to hide that 4, your right minus your left, so 0 minus 2. And then your right minus your left, so -2 minus 0. Use a calculator if you need to. Here we have a -2, -2, -2. So that means common difference is 2. Step number 2 is you're going to write out your formula. This is a different formula than what we have been using. And that formula is a little n, a sub n is equal to a little 1, a sub 1 plus d times n minus 1. So this is a sub n is equal to a sub 1 plus d times n minus 1. And because they want the nth term, we're going to keep the n and not change it. When we write it out, we're keeping that a sub n. The term in the first position is 4 plus our common difference is 2 negative. And we have an n minus 1. We need to distribute that -2. We get a sub n is equal to 4 minus 2n, negative, negative, positive 2. Combine like terms, a sub n is equal to -2n plus 6. This is your equation. Now this is a two-part question. It's asking you for the equation and it's asking you to find a sub 52. I'm going to separate this out. Once you have your equation, a sub n is equal to negative 2n plus 6, you're going to replace n with that 52. So a sub 52 is equal to negative 2 times 52 plus 6. The a sub 52, you don't do anything with it, keep it. It's the beginning of your sentence, but for the negative 2 times 52 plus 6, you're just going to type that into the calculator, and you get a negative 98. So the way to read this is the term in the 52nd position is negative 98. So if we continue this pattern until we get the 52 spot, that number is going to be negative 98. All right, moving on. Next one is going to be graphing. We're going to be graphing the arithmetic sequence. Now, when you're graphing, you're going to create a little t-chart. We got our n's, we got our a sub n's. This is our input, this is our output. Our input is our position number. So we have a sub 1, a sub 2, a sub 3, a sub 4. In the first position, we have number 5. In the second position, we have number 7. In the third position, number 9. And in the fourth position, number 11. So what you end up getting is you end up getting points for your graph. Now, these are discrete, so we are not going to be connecting. We got a 1, 2, 3, hold on. 1, 1, 2, 3, 4, 5, almost messed up there. 2 and 7, 1, 2, 3, 4, 5, 6, 7. 3 and 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And 4 and 11. So here's 9, 10, 11. Again, do not connect. This is discrete. So for a discrete domain and range, you're going to start off with squiggly brackets. You're going to take your x's, your inputs, and then you're going to list them out. So what's the smallest number? 1, then 2, then 3, then 4. For the range, same thing, squiggly brackets. What's the smallest number? 5, then 7, then 9, then 11. No repeated numbers are allowed, always from the smallest to the largest number. All right, this concludes the Chapter 4 portion of your test. The following questions are going to be from Chapters 1, 2, and 3. This is going to be for my class last opportunity for you to earn any extra credit for the semester. First question here, number 13. This is asking you to solve, which means combine like terms, get x by itself. So I see an x and an x. That means we're going to have to combine those together. Negative 4 plus 5 is going to be given a positive 1. So we're going to do a 1x here. I see an x, so I'm going to subtract 4 x's both sides. I get 9 and negative 3x. I have multiplication. I'm going to need to divide by negative 3. So that means negative 3 is equal to x after you divide. Next, we also have solve. Here we have parentheses, so we're going to need to distribute that 5. So 5 times negative 8, 5 times positive 6. 5 times negative 8 is a negative 40n. 5 times a positive 6 is a positive 30. And we have this minus 4n we're going to bring down equals 382. Do a dotted line. Combine like terms. So we have negative 44n plus 30. Bring down the 382. Combine like terms by subtracting 30. Bring down the negative 44n. Here we have 382 minus 30, which is 352. Divide by negative 44. So n is equal to a negative 8. Determine if x is equal to negative 16 is a solution. Do not solve. So what this question is asking, do you have a true statement or do you have a false statement? Can negative 16 be an answer? So when you do that, you're going to open up where your x is. You're going to take that negative 16 and you're going to place it in the spot of your x. You're not actually going to do any dotted lines, nothing like that. You're going to pick up your calculator and you're going to say 3, open, negative 16 plus 5. That's negative 43. Is negative 43 bigger or equal to 2? And that is not true. This is false. And what that means, it means that x equals negative 16 is not a solution. Let's do the same thing for the other one. Open up where your x is. Place that negative 16 inside. Type that into the calculator. Open, negative 16 close, divided by negative 4. I get 4. Is 4 bigger than 1? Yeah, that's true. So because it's true, yes, x equals negative 16 is a solution. For question number 16, we have solve the compound inequality. Is this an and or an or statement? So step number 1 is we want to get the inequality by itself. So anything inside the absolute value here, we want alone. So we're moving the 1 over. After we move it over, we're going to ask ourselves, is this an and or is this an or statement? So this greater than symbol is an or statement. So that means we're going to split it up and we're going to write this out twice. Whenever you write it out twice like this, removing the absolute values, you're going to flip the sign and the negative will become positive, positive will become negative, okay? So for us, positive will become negative after you flip the sign. For the other one, keep the sign, keep the number. Here you're going to have 2 inequalities to solve. The steps are going to be the same. So for example, I'm adding 5 to both on all sides. But then you'll notice that numbers change. So we got negative 15 here and a 25 here. Divide by negative 2. And I'm a little bit running out of space here, so we'll try to make it work. X is equal to negative 15 positive 15 halves, because negative negative gives me a positive. And for the other one, divide by negative 2. X is greater than, ooh, you guys, I put an equal sign. And I almost made a mistake here. So let's pause for a moment. Negative 25 halves. Here's the question that I forgot to ask myself. Did I multiply or divide by negative? I divided by a negative. And that negative was a negative 2. So I almost forgot. Whenever that happens, you're going to need to flip the sign. So this less than, when we bring it down, is going to change. This greater than, when we bring it down, is going to change. So I need here a greater than, flip it. I need here a less than. Now when you write your answer, if it's an or, you have to write or. If it's an and, you have to use the proper notation. So x is greater than positive 15 over 2, or x is smaller than negative 25 over 2. 25 halves. All right, that's your answer. Let's see if we have any more questions. We do. Just a couple more, beautiful people. We're almost done. All right, describe the transformation. So this is a 2-part question. We want to describe, then we want to write the equation. I'm going to try to move a little bit faster here. I did get a notification that my battery is about to die, so hopefully I will make it inside means opposite of what you see. This is a right 2. Outside is exactly what you see, so this is an up 3. This here you have to use a vertical stretch by 2. All of these words are necessary. Since we have an inside, we're taking our original function and we're opening up where that x is, and we're going to be placing that x minus 2 on the inside. Since here we have the outside, we're taking our function, keeping it exactly the same way, and the outside 2 and positive 3 are going to be on the outside of the function. Distribute, we get 5x minus 10 plus 1. So our equation is h of x is equal to a 5x minus 9. Here, again, distribute 10x plus 2 plus 3. So our h of x is equal to 10x plus 5. Okay, last one. We are trying to find if this is discrete or continuous. Are they connected or are they not connected? Points that are connected are continuous. Does it pass the vertical line test? If I draw a vertical line, does it hit once or twice? Twice. Is this a function? No. Does not pass the vertical line test. And I'm okay. I saw someone do that on the last test and I enjoyed the VLT, so I'm okay if you keep doing the VLT, vertical line test. I understand that. Now let's talk about domain and range. I'm going to draw this out really quickly. And again, I apologize for the speed just because my battery's about to die on my computer. I'm going to sketch this out really quickly because I don't want to mess with the original. For the domain, domain talks about your x values. So we will be looking on our x-axis. On our x-axis, what is the furthest point on the negative side that we can go? So if we're taking a look at our original, dragging it down, it is at -3. Notice we have arrows. Arrows are two-dimensional. We're going up and over. We're going over and down. Because we are going over on the x, that means we're going over to a positive infinity. This is continuous, so we are not listing out our topics, our x values. Instead, we're using inequality notation to represent from -3 all the way to positive infinity. Positive infinity does not have the or equal sign. Let's talk about our y's. Y's go up and down, so we're looking at the arrows. Arrows are going up and down. So that means there are no actual values to the y. Like, for example, on x we had a -3. We don't have any of that. Why? Because it always continues up, 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 and it always goes down, down, down. So our inequality from -infinity, y is our range, to positive infinity is the answer for the range. Thank you, beautiful people. We have made it to the end of the video, and my computer is still on, so I'm very happy about that. Enjoy the rest of your day. Bye.